lecture we continue the discussion on minimizing intercell moves. In previous lectures we have seen that minimizing intercell moves can be done in multiple ways. One is alternate machines alternate process plan, machine duplication, part subcontracting, operation subcontracting, etc. Out of these 5, we will concentrate on the alternate process plan, machine duplication and part subcontracting, knowing fully well that from the solution to the cell formation problem, which could come out through any of the algorithms that we have seen, it is always possible to find out whether a particular operation can be done on an alternate machine, or which are the operations to be looked at so that they can be done on alternate machines within the cell, plus operation subcontracting. The final solution also gives us a feel of what are the components for which we have to look at alternate process plans, as well as what are the components or parts that can be subcontracted and machines that can be duplicated. But we will look at these 3 in a little more detail and try to formulate problems that will address the issues of alternate process plan, machine duplication and part subcontracting. So, we take this example. This is a 5 machine 4 part incidence matrix. You actually see 6 columns, but the first 4 columns represent 4 parts, the 5 rows represent 5 machines. The columns 5 and 6, where we have shown 1 and 4 in brackets, mean that this is an alternate process plan to do part 1 and this is an alternate process plan to do part 4. So, part 1 can be manufactured using a process plan that follows a sequence or that visits machines 1, 3 and 5, or part 1 can also be done by visiting machines 2, 4 and 5 as an alternate process plan. Similarly, column 6 or process plan 6 is an alternate process plan to make part 4. So, now we want to group the machines and parts such that we minimize intercell moves, at the same time making sure that every part is assigned to a group based on one process plan. If we take these 6 parts, part numbers 2 and 3 have only one process plan, while part numbers 1 and 4 have 2 process plans. So, we have to choose one of them and then assign the part to a group based on the chosen process plan. So, let us look at formulations of this problem and let us see how we modify the Bochter's formulation as well as the P median formulation to include alternate process plans in our analysis. Now, let us look at the Bochter's formulation. Bach's formulation. Now, the Bach's formulation will minimize which represent the intercell moves x I k equal to 1 if machine I goes to cell number k, or and y j k equal to 1 if part j goes to cell number k. We have already seen that this minimizes the intercell move, and since it is counted twice, the half is also brought in. Now, the only catch here is j will be from 1 to 6 because there are 6 process plans. So, we calculate j equal to 1 to 6. Subject to the condition sigma x I k equal to 1 summed over k for every I. Each machine goes to only one group. Y j k equal to 1 for every j summed over k. Each process plan goes to only one group. Here j does not represent parts, j represents process plans. J represents process plans and does not represent parts. So, each process plan will go to only one group. Now, if we look at parts containing alternate process plans, that is part number 1 and part number 4, ordinarily part number 1 will, this constraint for part number 1 will be y11 plus y12 equal to 1, saying that part number 1 will go to either group number 1 or group number 2. Now, if we do this, then what will happen is we will end up assigning both part number 1 as well as part number 5, or process plan number 1 or process plan number 5. We do not want to do that, we want to choose only one out of the process plans. Therefore, this particular constraint is modified and written as y11 plus y12 plus y51 plus y52 equal to 1. So, only one of these 4 will be chosen, which means one of these 4 will be chosen, which clearly means either 1 will be chosen or 5 will be chosen, both will not be chosen. So, only one out of the many alternate process plans for part number 1 will be chosen, and that will either be assigned to group number 1 or group number 2. So, here there will be only 4 constraints. The first constraint will be like this, the second constraint will be y21 plus y22 equal to 1, the third constraint will be y31 plus y32 equal to 1, the fourth constraint will be y41 plus y42 plus y61 plus y62 equal to 1. So, that process plan 2 is chosen definitely and goes to either group 1 or group 2, 3 is chosen, it will go to either 1 or 2. As far as part number 1 is concerned, either process plan 1 is chosen or process plan 5 is chosen, and the chosen process plan can go to either group number 1 or group number 2. In a similar manner, for part number 6 also, either process plan 4 or process plan 6 is chosen for part 4, and the chosen process plan will either go to group number 1 or go to group number 2. Plus we need to have a restriction sigma xi k summed over I is less than or equal to some n for every k, unless we do that it will put all the machines into a single group. So, we will have to add this for the Bakhta's formulation. Now, let us see what happens to the solution. Now, here we have said that the optimum solution is given by x11 equal to x31 equal to x51, x22 equal to, now the optimum solution is given by machines 1, 3 and 5 forming one group and machines 2 and 4 forming one group, with parts y11, y61. So, 1 and 6 are chosen and 2 and 3 are chosen. Now, let us try and compute the intercell moves. Process plan 1 goes to 1, 3 and 5, no intercell move. Process plan 2 goes to 2 and 4, no intercell move. Process plan 3 goes to 2, 4 and 5. So, process plan 3 goes to 2, 4 and 5, there is one intercell move. There is one intercell move. 4 is not chosen, 5 is not chosen, 6 is chosen with 1, 3 and 5, there is no intercell move. But let us go back to this formulation. As far as this formulation is concerned, both, now in this solution process plans 4 and 5 are not chosen. So, in this solution y41 equal to y42 equal to 0, y51 equal to y52 equal to 0. Now, the way this objective function will be calculated is, since y41 is equal to 0, process plan number 4 requires visits of machines 1, 2 and 3. So, we will have a situation where there is a visit A14 from this matrix, there is a visit A14, x11 is 1, y41 is 0, because y41 is 0. So, this will contribute to an intercell move based on the objective function, because the way the objective function will calculate the moves, it will do summation aij absolute value of xik minus yjk. So, somewhere it will look at a term where A41 is 1, so A41 is 1, and it will look at A41 into absolute value of x41 minus x11 A14 equal to 1, part family number 4 requires machine number 1 from this matrix, and then it will have x11 will be 1, y41 will be 0. So, this will calculate one intercell move here. It will calculate two more intercell moves, A24 into absolute value of x22 minus y42 and A34 into absolute value of x31 minus y41. Now these 3 moves come because process plan number 4 that is not chosen has 3 elements in the corresponding column. Similarly, for the process plan 5 that is not chosen, it will compute 3 intercell moves A25 into absolute value of x22 minus 5y2 y phi 2. Now A25 is 1 from the matrix, x22 is 1 from the solution, y phi 2 is 0 because process plan 5 is not chosen. So there are 2 more intercell moves that it will calculate. So for the 2 process plans that are not chosen, it will effectively calculate 3 plus 3 6 moves. 3 comes because each of these process plan has exactly 3 elements in the corresponding column. So this objective function computation is an overestimate of the computation of the intercell moves. The actual intercell moves is not, this is an overestimation of the actual intercell moves. So we should do minus, in this case 3 times now we know that either process plan 1 is chosen or process plan 4 is chosen. We are not going to choose both. So we should have 1 minus y11 minus y12 minus y41 1 minus, we will have 3 times 1 minus y11 minus y12 minus 3 times 1 minus y41 minus y42 minus 3 times 1 minus y51 y52 1 minus y41 minus y42 1 and 5, 4 and 6 minus 3 times 1 minus y61 minus y62. Let me explain this addition. Now between process plans 1 and 5, we are going to choose only one of them. Now this constraint will ensure that one of them is chosen, either 1 is chosen or 5 is chosen. If 1 is chosen, one of these 2 put together will take a value 1. This is put together will take a value 0. So if you look at this, if 1 is chosen, process plan 1 is chosen, as in the example, if process plan 1 is chosen, one of these 2 terms will be 1 and this thing will become 0. Now 5 is not chosen, therefore both of these will be 0 and this will contribute a 3 to the other one. The 3 is contributed because process plan 5 requires 3 machines, and those 3 this will consider. So you should remove the 3 from there as the intercell move, because as such they are not intercell moves. Similarly, between process plan 4 and process plan 6, only one of them will be chosen. So in our example 6 is chosen, which means one of these 2 is 1, the other is 0. So this term will be 0, whereas 4 is not chosen, so both are 0. So this will contribute a minus 3, because by not choosing the process plan 4, we are actually adding 3 that comes here. I explained now how each one will add 2 times. So there will be 6 contributions. This half will ensure that it is 3 and that 3 is taken away. So this is how the Bochter's formulation has to be modified if we are using alternate process plans. An optimum solution to this problem would give us the correct choice. Now, in order to modify the p median problem, now we consider this matrix. Now there are 6 process plans. So we are doing a p median problem for process plans. Not for parts, for process plans. So it becomes a distance matrix or a dissimilarity matrix becomes a 6 by 6 matrix. So minimize Dij Xij subject to the condition. Let us go back to the p median formulations. Sigma xjj equal to p, xij less than or equal to xjj, and sigma xij equal to 1 summed over I or summed over j for every I. Now we will compute a 6 by 6 distance matrix which is like this, which is shown here. Now we are going to choose either we are going to choose 2 medians out of 1, 2, 3, 4, 5, 6. At the same time we have to make sure that 1 and 5 are alternate process plans. So 1 and 5 should not become 2 medians, only one of them has to be a median. So we will add a constraint x11 plus x55 is equal to 1. Will be equal to 1. Similarly, x44 plus x66 is equal to 1. Both cannot be chosen as medians. Now, or in fact less than or equal to 1, so that we can have a situation by which both are also not medians. We could have in this case 2 and 3 coming in as medians. So to ensure that both cannot be medians, we choose x11 plus x55 less than or equal to 1 and x44 plus x66 less than or equal to 1. So these two constraints will ensure that both 1 and 5 are not medians. Now we have 6 constraints that are here. Now these 6 constraints ordinarily would be, for example, it will be like x11 plus x12 plus x13 plus x14 plus x15 plus x16 equal to 1 for the first process plan in the original p median formulation. Now there will be one for process plan number 5 also, which will look like x51 plus x52 plus x phi 3 plus x phi 4 plus x phi 5 plus x phi 6 is equal to 1. There will be one for 2, 3, 4 and 6 also. Now let us take the case for process plan 1 and process plan 5, because process plans 1 and 5 are alternate plans. We are going to use only one of them, we are not going to use both. So what we do is we simply put a plus and say the whole thing should be equal to 1, which means between points 1 and 5 in the p median formulation there are two medians. I will take one, either 0.1 or 0.5 and try to put it to the nearest median, because I am minimizing a dij xij. So this will also make sure that if 1 is assigned to a median, 5 cannot be assigned to a median. If you take point number 1 can either be a median or will be assigned to another median. So it will be a median if x11 is 1. That will automatically ensure that x phi 5 is 0, which will satisfy this. So 5 cannot become a median if 1 is a median. Similarly, if 5 becomes a median, 1 cannot be a median. Now if 1 and 5 are not medians, then they have to be assigned to another median. So this will make sure that they will be assigned to another median, but both will not be assigned, because the entire summation is equal to 1 will ensure that either 1 will go to a median or 5 will go to a median, such that the distance is minimized. So a similar constraint is written for 4 and 6. So that will be written as x41 plus x42 plus x46 plus x61 plus x62 plus 63 plus 64 plus 65 plus 66 is equal to 1. The other 4 constraints will remain like this. The other 2 constraints for 2 and 3 will remain only up to this part. So that is how these 6 constraints will now become 4 constraints. xij less than or equal to xjj will stay intact, except that for all 6 we will do that. xjj equal to p will also stay intact. This will ensure that alternate process plans both do not become median. It will get little more complicated when for a particular part there are 3 alternate process plans. Now if there are 3 alternate process plans, then they will become as additional columns, and now instead of these 2, for example, if we had for part 1 the process plans were 1, 5 and another 7, then this will be 1, 1 plus 5, 5 plus 7, 7 less than or equal to 1, and here there will be a third addition for 7, which will ensure that it does not go. So this is how the p median formulation can be modified and once again solved optimally to get the solution with alternate process plans. We would get the same solution here when we actually do that for this instance, where the same set of solutions given earlier with machines 1, 3 and 5 forming one group, 2 and 4 forming the other group, process plans 1 and 6 chosen and 2 and 3 chosen into the other one. The other possibility also is by using the distance matrix or dissimilarity matrix, we can also have a heuristic algorithm which will do that. For example, we will now look at the distances or dissimilarities for the part families. So let us look at the original one. This is the original one. So let us look at between 1 and 2 the distance is 0. Between process plan 1 and process plan 2 the distance is 0. So we look at this. So this represents a distance matrix or a dissimilarity matrix. So we can use a similarity coefficient based method or a distance based method. So where there is a 0, we can ensure that these 2 will belong to, when the distance between 2 process plans is If we look at this, process plan 1 has visits machines 1, 3 and 5, process plan 2 visits machines 2 and 4. So, the similarity is 0, the distance or dissimilarity is 5. Now, you can see that similarity is 0 because there are 5 pairs, all of them are 1 0 or 0 1 pairs, 1 0 0 1 1 0 0 1 1 0. So, similarity is 0, distance is 5. Therefore, this matrix is a similarity matrix. So, when we use P median on this matrix, we will maximize Sij Xij and not minimize Dij Xij. So, now since it is a similarity matrix, we will go back to this matrix and find out which are the process plans that have maximum similarity. So, 1 and 6 have maximum similarity with 6 from this. So, 1 and 6, now this is process plans, this is group 1 process plan 1 and 6 are given to group number 1. Next highest is for 3 and 5. So, next highest is for process plans 3 and 5, but then we know that 1 and 5 are alternate process plans and 1 has already been assigned to this. So, 5 will not be considered. So, next highest will be, as we see, is 2 and 4, 2 and 5 with similarity equal to 4. Now, once again we realize that 5 is an alternate process plan for this, therefore, it does not go. The next highest is 1 and 4, once again it does not go because 1 is already chosen. Then we look at 2 and 3 and we now put 2 and 3 into the second group. So, the reasoning behind this is we have implicitly assumed that there will be a maximum of 2 process plans in a group. Otherwise, we could have looked at some other way. For example, if we had chosen 1 and 6 here, if we go by this, the highest similarity was 6, which gave us process plans 1 and 6 here. Next highest similarity is 5, which is for 3 and 5. 3 and 5 have 5. Now, we know that 1 and 5 are alternate process plans, but we have chosen 1, therefore, we cannot choose 5. We cannot add a 3 here because 1 and 5 are the same. They are not the same, they are alternate process plans. We either use this or use that. We cannot have both. So, we will not look at the similarity coefficient of 5 between 3 and 5. We look at the next one, which is 4 between 2 and 5. For the same reason, we will not look at that because 5 has to be left out. Next highest similarity is between 1 and 4. Once again, 4 and 6 are alternate process plans, so that is left out. Next highest happens to be for 2 and 3. So, either we could put 2 and 3 here or here. Because we have a restriction that we will have a maximum of 2 process plans in a group, 2 and 3 will come into another group. Now, once the part families or process plan families are chosen, you can apply the machine allocation rule to allocate machines based on the chosen process plans. So, now this we will look at process plan number 1 requires, or we go to machines, machine 1 does 1, 4 and 6. Actually 4 and 6 are alternatives, so 4 should not be looked at. So, it does 1 and 6, so machine 1 will go here. Machine 2 does 2, 3, 4 and 5. Machine 2 has 2, 3, 4 and 5. 4 is not to be looked at because 6 is chosen. So, it has 2, 3 and 5. So, machine 2 will come here with 1 intercell move. machine 3 has 1, 4 and 6. Once again 4 has to be left out because 6 is chosen. So, 1 and 6. So, machine 3 will come here. Machine 4 does parts 2, 3 and 5. Machine 4 does 2, 3 and 5. So, it will look at 2, 3 and 5. So, machine 4 will come here and machine 5 does 1, 3, 5 and 6. So, 1 and 5 are alternate process plans. So, machine 5 looks at 3, 5 and 6. Sorry, 1, 3 and 6. So, machine 5 will come here. Once again machine 5 has 1, 3, 5 and 6. Now, out of these 1 and 5 are alternate process plans, 1 is chosen. So, 5 has to be left out, it does 1, 3 and 6. So, it goes to group number 1. So, this is how the machine groups are also formed through this. So, this is how we bring in alternate process plans into the formulation stage, and either we can modify the Bakhter's formulation to do it, or modify the P median formulation to do it, or have a similarity coefficient based approach which considers alternate process plans. So, we will now look at the next one, which is the problem to duplicate machines. This picture shows the old example, the familiar example where there are 6 machines and 8 parts, and this is the solution obtained using the earlier P median model or the Bakhter's formulation, etc. So, from this we know that if we were to duplicate a machine, we will be duplicating machine number 6, because it has 3 intercell moves from the first group. So, one way to capture machine duplication is by looking at the block diagonal structure itself, and from the block diagonal structure trying to find out which is the machine that is attracting a lot of intercell moves, and that will be the first candidate to duplicate. But then we have to quickly say that this block diagonal structure has been obtained, assuming that it has been obtained using an optimization. So, one way is to look at an optimum solution without considering machine duplication, and from that solution try and find out which are the machines to be duplicated. The other way is, right at the optimization stage itself, can I bring in the idea of machine duplication and simply solve one problem, which at the end of which will give me a solution with machines duplicated. So, that is the purpose of revisiting these formulations by considering machine duplications and part subcontractings and so on. So, we go back to the Bakhter's formulation. So, intercell moves again will be minimize half into Aij into Xik minus Yjk. This will be the intercell moves, subject to the condition that each machine is assigned to only one group summed over k. Each part is also assigned to only one group Yjk, and a restriction on the cell size Ik summed over I is less than or equal to n for every k. This is the Bakhter's formulation, original formulation. Of course, we have seen how to linearize the term and so on. Now, if we allow machine duplication, where is the modification? This constraint permits a machine to be attached to only one cell. This permits a machine to be attached to only one cell, and this does not allow a machine to go to 2 cells. For example, if we are looking at 2 groups, we will have a constraint which is x61 plus x62 equal to 1 for this table, and that will force machine 6 either to group number 1 or to group number 2. So, the only thing that we have to do is we could say greater than or equal to 1, xik xjk greater than or equal to 1, that we have. But x ik is also binary, which means we are basically allowing a constraint of the type x61 plus x62 greater than or equal to 1. We are also allowing x51 plus x52 greater than or equal to 1 and so on when we write this. But this is going to help particularly in duplicating machine number 6 in both of them. But again we restrict that we could have one machine of 6 in the first group and one in the second group. They are still binary. So, this will not have more than one machine of 6 in one group. So, this is enough to do this. At the same time, for each of these machines we write this. So, when we write this for each of these machines and solve, if we look at this particular solution, which is the final block diagonal form, if we duplicate machine 6 alone, there would still be 2 intercell moves. If we duplicate machine number 5, there will be 1 intercell move, and we duplicate machine number 2, there will be 0 intercell moves. So, the actual solution with 0 intercell moves is when group 1 has 1, 2, 3, 4, 5, 6 and group 2 has 2, 5, 6. But you also know that the moment group 1 has 1, 2, 3, 4, 5, 6, you can always have a solution where all parts go to group 1 and no part goes to group 2. Therefore, it will at the end give you a trivial solution where all of them go to only one group, the other group does not attract anything. So, in order to prevent that, we have this. This will ensure that all of them cannot go to one group, because this n will be less than or equal to 6. So, we need to fix this n very carefully, so that all of them do not go to the same group. In the process, we are also duplicating machines, and the number of machines that are duplicated is given by sigma xik minus 1. For example, if we are adding a 6 to the first group and to the second group, so x61 and x62 will be 1. So, sigma x6 will be 2, 2 minus 1, 1 will ensure that there is one extra machine of 6 which is duplicated. So, similarly, the extra machines that are duplicated is this. So, we could also put a restriction that the extra machines that are duplicated is less than or equal to some r or some number. I do not want to duplicate more than 3 or 4 machines in a large sized example. So, this is not a absolutely necessary constraint, but this would also help us to ensure that it does not throw up a solution where a large number of machines are duplicated. The reason is machine duplication involves a cost. Explicitly, we are not bringing in the cost of the machine at this stage. The other way to look at it is we assume that all machines are equally costly, and therefore we say that we will minimize the number of machines that are duplicated. We may use this, we may not use this, but this has to be done very judiciously such that all the machines do not go to the same group. So, this is how the Bakhter's formulation is modified. Now, the Bakhter's formulation can be modified to this problem, and if we allow a cell size of 4, let us say, then we will get the solution where this machine number 6 is duplicated to the first group also. So, first group will have 1, 3, 4 and 6, second group will have 2, 5 and 6 if we allow 4 here. If we allow 3, it would still have the same solution even though we have allowed for machine duplication. So, n has to be chosen very carefully. Now, let us look at minimizing part subcontracting, or look at the case of what we do with respect to part subcontracting. Now, let us look at the same solution which is obtained through a cell formation algorithm. Now, there are 5 intercell moves and we want to reduce the number of intercell moves. So, we said one of them is to try and do part subcontracting. Now, if we were to choose one part that we will subcontract, which means we will take it out of the incidence matrix, then that will be part number 6, which is now the 4th column of the table. Because if we take out part number 6, 2 intercell moves are going, but if we take out part number 6, actually 5 moves are effectively going. 5 moves are effectively going if we take out part number 6. So, the part subcontracting problem is to say that amongst these parts, which are the parts that are going to go into the cell, which are the parts that are going to be subcontracted, such that we minimize the intercell moves. So, now in the earlier case we will have yjk equal to 1 if part j is assigned to cell k. And if there are 2 cells, we would have a constraint y11, or let us say part number 6. So, we would say y61 plus y62 is equal to 1. Now, we have an alternative that the part can also be subcontracted. So, y61 plus y62 plus some z6 equal to 1 if z6 is part 6 is subcontracted. So, the formulation has to be modified accordingly for subcontracting. So, how the Bakhter's formulation can be modified for part subcontracting, we will see in the next lecture.